Hey everyone, my name is Lucky Chitupoli, and today we will be going over some SAT math problems in the No Calculator section. Our first problem is x plus y equals 75 is the equation we're given, and the problem is the equation above relates the number of minutes x Maria spends running each day and the number of minutes y she spends biking each day. In the equation, what does the number 75 represent? And the options are A, the number of minutes spent running each day, B, the number of minutes spent biking each day, C, the total number of minutes spent running and biking each day, and D, the number of minutes spent biking for each minute spent running. Okay, so let's look at the equation again. We have x plus y equals 75, and x and y, x we are given that is that x is the total number of minutes Maria spends running and y is the total number of minutes Maria spends biking. So x plus y would equal the total number of minutes running plus the total number of minutes biking each day. And from that expression we get 75, and since we're adding x and y, 75 should be the total number of minutes Maria spends running and biking each day. So from the answer options, our answer would be C, the total number of minutes spent running and biking each day. So for our second problem, we have which of the following is equivalent to 3 times the quantity of x plus 5 minus 6? And our options are 3x minus 3, 3x minus 1, 3x plus 9, and 15x minus 6. So, first, let's write out the problem. 3 times x plus 5 minus 6. And in this case, we're going to be using the distributive property to distribute 3 to everything in the parentheses. So in that case, 3 times x is 3x, and 3 times 5 is 15. And we still have to write minus 6 because that was part of the original expression. So we're not just finished with this problem yet. We have to further simplify this, and so we have 3x, and 15 minus 6 is 9. So the most simplified answer would be 3x plus 9, and in our answer options, C is 3x plus 9. So C would be our answer. For our next problem, there are multiple ways to solve this system of linear equations, but I will be using the substitution method. So first I'm going to take the first equation, x equals y minus 3, and reframe the equation to be y equals x plus 3. Next, with y equals x plus 3, I'm going to plug that into the second equation. So we have x over 2 plus 2, and here we plug in our y, which is x plus 3 equals 6. So now we have to simplify. So I'm going to distribute 2 within the parentheses. So that would be x over 2 plus 2x plus 6 equals 6, and we can subtract 6 from both sides, so it would be x over 2 plus 2x equals 0. Therefore, x would also equal 0. Now with our x value, we would plug it back into the first equation. So once again, our first equation was x equals y minus 3. And since we have x equals 0, we could plug that in and write 0 equals y minus 3. Therefore, y would equal positive 3 because we're adding 3 to both sides. So now we have our x value and our y value. So our ordered pair would be 0, 3, and that's because ordered pairs are written x, y. So the answer with the order paired 0, 3 is option B, so that would be our answer. For our next problem, we have which of the following complex numbers is equal to 5 plus 2i minus 9i squared minus 6i, where I, which is an imaginary number, equals square root of -1. So first of all, let's write down the problem. Minus 9i squared minus 6i. So now let's write this out without the parentheses. So we would have 5 plus 12i, and since there's a negative sign, we do negative 9i squared. And since there's a negative sign again, we do negative times a negative, which is a positive. So using distributive method, it would be plus 6i. Okay, so next we would take in consideration I, and we know that I is the square root of -1, but let's see what I squared is. So we take the square root of -1 and multiply it by itself, and that would just be square root of -1 squared. So the square root and the square would just cancel out. So I squared would just be -1. Check out my other video about imaginary numbers for more information. So anyways, back to the problem. Here we have -9i squared, so for I squared, we can just plug in -1. So let's rewrite the whole problem. 5 plus 12i minus 9 times -1 plus 6i, and now we can just further write this more simplified. 5 plus 12i, and -9 times -1 is +9, so plus 9 plus 6i. Now we can just add up the like terms, so we know 5 plus 9 is 14, and 12i plus 6i would be 18i. We don't need to multiply it by square root of -1, that is not necessary, so we can just leave it as 14 plus 18i. And let's check our answer options, and the answer with 14 plus 18i is option D. Thank you for watching my video about different types of SAT problems, and I will continue to make the SAT and ACT math problem series, and they will vary between the no calculator section and calculator section within the SAT and math portion of the ACT, and normally take about 4 questions per video. Once again, thank you.